myself, Prem Prasad Dattatre Petkar. I'm a final year student and in Electronics and Telecommunication Department at Government College of Engineering, Jalgaon. I'm here to present my project presentation video of Embedded System Internship of Project Microwave Oven Simulator using microcontroller PIC16F877A provided by Emerzi Information Technologies in the month of December. Now, the outline of my presentation means the things which I will cover in the presentation is the goal of internship, the key takeaways from the internship, embedded C fundamentals, brief overview of embedded system, its types and its core component. And next I will cover all the project details including my project overview, problem statement, various software and simulator tool used, block diagram of project and functional requirement of project, and at last I will demonstrate my project video. Now let's see first the goal of internship. Uh, this internship provided by Emergis Technologies was a very practical oriented internship in which it was focused for students to learn on C fundamentals and embedded C programming. It provided students to practical understanding of embedded systems. It helps me to work with microcontroller and its peripherals such as LED, buzzer, CLCD, fan. It helps me to understand requirement analysis and design, and it provides me opportunity to implement a real-time embedded project microwave oven. Next, I will cover key takeaways from the internship. This internship was divided into a modules. In the first modules, I learn about complete about embedded C. In embedded C, various elements are covered such as data types, keywords, conditional constructs including conditional statements and loop, various types of operators, arrays, pointers, functions, and preprocessors. Also, in another module, we studied about embedded system and also about the microcontroller PIC16F877A, in which I studied pin diagram configuration, timers, and interrupts in this microcontroller. Also, it helps me. It improved my knowledge about hardware such as LED, switches, CLCD, key matrix keypad, buzzer, and fan. Now, let's see the concepts one by one. So, basically, a programming language has a three layers. A low level language has a three types of. There are mainly three types of programming language: low level language, medium level language, and high level language. Low level language is a language e- which is a language of machines, means the language which is easily understood by machines, such as binary language or machine level language. But this language is very hard for humans to program. Then comes middle level language. This language is uh, little bit uh, easy to understand because it is not it is less dependent on hardware. And the next come high level language. High level language is a hardware independent language, and uh, it is easily understood by human beings. So in middle level language, there are various advantages of using middle level languages, like it combines low level hardware access and high level programming, that is faster than high level language and easier than assembly language. The main advantage of middle level language such as C or embedded C is portability. The code supported in all the platform, suitable for the systems and embedded programming. There are various middle level languages such as C and embedded C. Now, the question may arise in your mind that what is the difference between C and embedded C? So, basically, a C is a general purpose programming language, while embedded C is a extension of C specially designed for embedded systems. The C language is used for building desktops and system software. And embedded C language are mostly used in programming of microcontroller based systems. The C language use OS based platforms and embedded C use RTOS based or bare metal based. The C language has no direct hardware access. An embedded C language has direct register or peripheral access. Execution. There is no strict real-time execution of C language, but in embedded C there is a real-time execution. In while programming in C language, there is large memory available, but in case of embedded C, we have to work with limited RAM and ROM. So there are critical conditions which are constraint that need to be satisfied while programming. Now, the C has various standard libraries, while embedded C has microcontroller specific headers. The main Now let's talk about portability. The C language has high portability, but the embedded C is hardware dependent. Means program written for PIC 16F77A might not be used as it is for program written for uh, ESP32. So here are various other details, and the next one is compiler. In C we used compiler like GCC or GNU. In embedded C we used compiler like XC8. Now let's see in detail the embedded system. An embedded system is a combination of hardware and software designed to perform specific tasks, and it works in a real-time environment. Means embedded system is a combination of hardware and software, and it is specially designed to do a specific task. Means any general system, we cannot say it as an embedded system unless it does only a single or a specific task. Like example of laptop. In a laptop also consists software and hardware, but it is general purpose that we can do multiple application using laptop. But if we take the example of washing machine, the washing machine contains the software loaded in it, and it has a hardware, and it has a specific task that it will wash the clothes, but it will not do another task. So it will perform specific function. Such systems are called as embedded systems. There are various examples of embedded system we use in our day-to-day life, such as microwave oven, smart mixers, washing machine, automotive ECU. Now, there are mainly four types of embedded systems based on functionality and performance. The first one is real-time embedded system, then standalone embedded system, network embedded system, and mobile embedded system. So let's see one by one. The first one is standalone embedded systems. A standalone embedded systems operate independently to perform a dedicated function without without requiring a host computer, such as microwave or washing machines. Means the systems which are not dependent on any other thing to perform tasks. Uh, example microwave oven, in which all the required programs are loaded into a same microwave, and there is no need uh, at each time of using to load the program. Then next come real-time embedded system. A real-time embedded systems are designed to produce output within a specified time constraint and are classified as hard real-time embedded systems and soft real-time embedded systems, where missing deadline causes failure. And in soft real-time embedded systems, occasional delays are expectable. In real-time embedded systems are basically the embedded system which need to process data in real time. And there are mainly two types. Hard real-time embedded system means if the system provide delay or doesn't respond to in real time, then there might be a system failure. But the soft Real-time systems are in systems in which delays are acceptable. Example, uh, streaming of a live match, in which delays are uh, acceptable. Then next one is networked embedded system. Networked embedded systems are connected through wired or wireless networks to exchange data and enable remote monitoring and control, and it is commonly used in IoT and smart home applications. The next one is mobile embedded system. Mobile embedded systems are portable, battery operated systems designed for low power consumption and compact size, such as smartphone and wearable devices. Hybrid embedded systems. Embedded systems, which is combination of more than two of the above embedded systems, are called as hybrid embedded systems, such as mobile phone. A mobile phone is also a network embedded system and also a mobile embedded system. So we can classify mobile as hybrid embedded system. Now let's see the components of embedded systems. There are basically two main parts of embedded system: embedded software and embedded system hardware. In embedded software, it consists of RTOS, firmware, application software, and device drivers, while embedded system hardware consists mainly of microprocessor or microcontroller, network interfaces, I/O devices, peripheral interfaces, memory unit, and power supply. Now, let's see hardware components. The In any embedded system, microprocessor or microcontroller act as a brain of embedded system, and for storing the programs, there are various memories are available in each embedded system, such as RAM, ROM, and to process the real world data, we need A to D converter and DA A to D converter and DAC converters. Now let's see what's the difference between microprocessor and microcontroller in terms of its architectures. Microprocessor is mainly a CPU core only. It requires external memory and peripherals. Microprocessors are generally used in PC and complex systems. Microcontroller. Microcontroller is a computer on board. Like, it consists of CPU, memory, peripherals integrated on one chip, optimized for embedded control tasks. Now, there are mainly two types of architecture used in microcontroller. That is hardware architecture and von Neumann architecture. In hardware architecture, separate memory and buses for instruction and data are available. It enables faster parallel access of data, and it is mostly common in microcontroller. And in case of von Neumann architecture, it has a single shared memory and bus for instruction and data. It is simpler but can cause bottlenecks. And von Neumann architecture are typically used in microprocessor. The key difference between microprocessor and microcontroller is microcontroller are still self-contained embedded controllers, while microprocessor are general purpose CPUs needing external components. Now let's see various types of memories which we required in embedded systems. First one is ROM, that is read-only memory. It is in non-volatile in nature. There are various types of ROM, such as PROM, programmable read-only memory, means it can be programmed only once. Erasable programmable read-only memory, erased using strong ultraviolet light. EEPROM means electrical erasable programmable read-only memory, erased and reprogrammed electrically, used to save settings. Flash memory, it is a modern EEPROM used in PIC microcontroller for entire program project. Then Next main classification of memory is RAM, random access memory. It is in volatile in nature and it is temporary memory. There are two main classification or sub-classification of RAM, that is SRAM, static random access memory. It uses flip-flop to store data. It is fast and does not need refreshing. Project use stores active variables like remaining cooking time. DRAM means dynamic random access memory, uses capacitors and require constant refreshing, typically used in general purpose computer, rarely in small microcontrollers. Next, we will see the project overview. My project was microwave oven simulator using PIC 16F877A. The I in which I have simulate the basic microwave oven operations. Implements I have implement multiple cooking modes and user interactions via keypad and LCD. Now, before moving to a microwave oven simulator, let's see in short what is microwave oven. A microwave oven is an electronic cooking appliance used to heat or cook food. It works by generating microwave radiation around 2.45 gigahertz. Microwave cause water molecules in food to vibrate and producing heat. This method allows fast and uniform heating. Example, reheating rice or milk in few minutes. Now, there are various modes in microwave. In this project, we have taken only a four basic modes. The first one is micro mode. This mode uses microwave radiation for heating. It is suitable for reheating and simple cooking. Example, heating leftover food. Second one is grill mode. It uses heating element to brown food. It is used for grilling and crisping. Example, grilling sandwiches or paneer. The third mode is convection mode. Uses hot air circulation along with heating. Suitable for baking and roasting. Example, baking cake or pizza. Start mode. Start microwave with default time, usually 30 seconds, used for quick heating. Example, warming water quickly. Now let's see in detail about the microcontroller which we have used in this project, like PIC 16F877A. In this project, we used 16 PIC 16F77A microcontroller with the following specification, in which its bus width was 8 bits. It, it has total 40 pins and 33 pins for input and output. The program memory of this microcontroller is 14.3 kilobytes. The CPU speed of this processor is 5 million instructions per second. The RAM size of this uh, board is 368 bytes and the EEPROM size of this microcontroller is 256 bytes. Now let's see the architecture of board. In this project, I have used the PicGenius board on PicSim simulator, and the various specification and architecture is given below. Like the board architecture integrate the PIC 16F877A as a central controller connected to. It has various inputs peripherals like LM32, LM35 temperature sensor, digital keypad, matrix keypad, and ADC. Various output peripherals like LED, buzzer, 7 segment display, and character LCD. And for communication purposes, it has various interfaces like RS232 interface, GPIO, and I2C interface. Now let's now in this project I have used software tools, MPLAB X IDE. MPLAB IDE is a free integrated toolset for the development of embedded application on microchip PIC and DSC PIC controller. It is called as Integrated Development Environment IDE because it provides a single integrated environment to develop code for embedded microcontrollers. The next tool I have used is PIC Fixing Lab, means PiximLab is a real-time emulator of development boards with an integrated MPLAB X debugger. It supports some P- PIC SIM microcontrollers and some SIM AVR microcontrollers. It has integration with MPLAB Arduino IDE for programming the board microcontrollers. The next tool I have used is XC8 compiler. XC8 is a C compiler developed by Microchip Technology, specially for their PIC microcontroller. It is designed to optimize code for these microcontrollers, providing efficient use of resources like memory and power. XC8 support ANSSIC and incorporates features tailored for embedded system development, making it popular choice for PIC-based project. The next we will see in short the peripherals I have used in this project. First one is LED. LED, as we all know, LED is a light emitting diode. It is a semiconductor device that emits light when the electrical signal passes through it. LED has is an external device connected to microcontroller port. The main application of LED in embedded system are used as a feedback device. Means it indicates as whether the system is on or off, whether the display is active, and it provides feedback for the user. The next peripherals I have used is character liquid crystal displays, that is CLCD. CLCD is a flat panel display technology that uses liquid crystal to modulate light and display images or text. LCDs operate by modulating light through crystal controlled by electrical signal. Alphanumeric LCD display module can display alphabets and numbers. It consists of 4 rows and each can print 16 characters. It can work on both 8-bit and 4-bit mode. The next one is interrupts. There are mainly two types of interrupts, that is hardware interrupts and software interrupts. And in hardware interrupts, there are two main subtypes, that is maskable interrupts and non-maskable interrupts. Interrupts in microcontroller are hardware or software signals that temporarily suspend the normal program's execution to handle a critical events or external stimuli. When an interrupts occur, the CPU suspends its execution of the current program and transfer the control to the interrupt service routine, also called as handler, that provides the requested service by the interrupt. When the ISR is completed, the original program resumes execution as if it is not interrupted. Now, let's see the interrupt service routine. Interrupt service routine tells us the processor or controller what to do when interrupt occurs. The next peripherals I have studied is fan. Onboard and passive cooling fans are now mostly used in all desktops, computing, and embedded systems. The next one is buzzer. In embedded system, buzzer is widely used to notify various events such as interrupt generation, end of the process, and in emergency situation, detection of fire. Now, the next topic is timers. Timers in microcontrollers are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing time critical operations. The microcontroller or processor understand only by the timers that how much times are passed and what action to take. The microcontroller PIC16F8778 has three independent timers. The basic terminologies used in timers. Resolution means the length of the timer register. Quantum means period of the tick. Scaling, it is a method where we can delay the process of going into the routine if required. Then watchdog timer. Watchdog timer periodically resets by system timer. If not reset, and interrupts to reset the host. The next one is block diagram. Um, Here is a block diagram of my project in which it consists of a microcontroller PIC16F877A. The output devices are attached to it: display, uh, matrix keypad, which is an input device, buzzer and fan, both are output device. The problem statement. Now, the problem statement of project was to develop the microwave oven interface and simulate it using embedded C. The system must display and allow the user to select different types of cooking programs like micro, grill, convection using matrix keypad. Upon starting a mode, the screen should display function running and the remaining time. The system should include safely or pause feature, allowing the user to stop or pause the process at any time. Now let's see in detail the functional requirement of the project. The first requirement was powering on the screen. Means whenever I power on the microcontroller or the device, it should show the power on screen message through on CLCD display. The next requirement was cooking mode screen. In cooking mode screen, in this requirement means uh, when the user turn offs the turn on the microphone the device, he should have the various mode to choose for cooking like micro, grill, convention and start. When the user choose one of the mode for in microwave oven for cooking, the means the functional requirement in this mode are, uh, are follows that the power consumed by that mode should be first appear on the screen. Then the user should able to set the timer, and he after timing is set, he should have the he or she should have the option of start, pause or stop. The same in case of grill mode. And in case of convection mode, uh, the user will have the option to enter the temperature, and by default setting, the microwave oven will set for default preheating at that temperature in degrees Celsius for a default time. And after that preheating, the user will enter the time of cooking, and then he will continue the cooking. Before moving towards conclusion, we will first see the demonstration video of the project. Towards the main part of this presentation, that is project demonstration. The first, I have written the code on MPLAB IDE, and I have extract the hex file of that code. Now I will select the microcontroller PIC16F77A. Then I will load the uh, hex file of that microcontroller in it. Um, so I have loaded the hex file. The first functional requirement was that it should display a power message. So when I have loaded the message, there is a message of powering on microwave oven. Means first functional requirement is satisfied. Next, uh, let's next I have the various options, means four options. First one is micro, second one is grill, third is conventional, four is start. Here first denotes that, means when I press one in this keypad, then first mode will be selected. When I press 2, then the second mode, grill mode, will be selected. When I press 3, the convection mode will be selected. And when the mode will be selected, I will let's in case of cooking in microwave oven, what we do, first we select a mode, and after selecting a mode we set like example baking a cake. When we bake a cake, first we will select the mode convention. So then we will set the temperature like example 100 degrees Celsius. We'll preheat the oven first for uh, 30 seconds. Then we will the we will load the cake into a microwave oven, and we will then set we will timer of 15 minutes. And after that 15 minutes we will get notify the buzzer will rank of from the oven that the timer is finished, time is finished, and the cake is ready. So the same demonstration here, instead of the real hardware, we are demonstrating on the this big genius board. The main objective of that project, that application is replicate on in this simulation. So uh, first I will select the micro mode. When I select the micro mode, the power capacity or the power consumed, that is 90 watt, is appeared on my display. Now it is asking me to set the timer, means how much time I have to set the food item for cooking. So let's set for 2 minutes 2 seconds. So I have set, I have entered 2 through the this matrix keypad, and now I'm setting 2 minutes 22 seconds. And for to enter the value I have to press hash. So after pressing hash means the timer is set off for 2.22 seconds, and now the fan is turn on, means the heater will start generating heat, and the fan will circulate this heat in the complete microwave oven space. So now if the user wants to pause the pause the timer and to do any other tasks in that product, so by pressing 5 he will pause the cooking. So I'm pressing 5. So after pressing 5 the fan got off, means the cooking means the timer is now stopped, and the we can remove that product, do some modification, and again insert it. And when after inserting we have to do again start. So by for start we will press 4 for starting. Now the cooking is started in micro mode. So in case of user want to terminate the cooking and to stop, we have to press 6. So after pressing 6 the session is stopped, and again we have options to for changing the option we have various options. Now I will select the grill mode. The grill mode is similar to the micro mode, but uh, there are some different uh, uses which I have explained earlier. Like now I am setting for 1 minute's timer, 1 minute 1 second timer. So now I will press enter. So now the timer is set for 1.10 seconds, 1 minute 10 seconds. Now the cooking is on. This is heater which will give the heat for the cooking item, and this cooler or this fan will circulate that heat in the uh, space. So this is a big genius board. It has matrix display. It has 7 segment display. It has various LCDs to indicate uh, the operation or status of that board. The main brain of this big genius board is PIC16F77A, which is this. It has double EEPROM memory. It has various port like A, B, C, D, and relays to control various motors or the drive, and the temperature sensor LM35, which the use of this sensor we will see in the next mode. So we will wait for 42 seconds until our cooking is going on. Now we wish to stop it and go for and to change our mode in another. So I have stopped the grill mode. Now I have to see the conventional mode. So I will press 3. So after pressing 3 means selecting conventional mode, there is a option to set the temperature in degrees Celsius. So we'll set the temperature 100 degrees Celsius. So to set the temperature 100 degrees Celsius, we have to enter 1 and 2 times 0. So for enter, we will place hash. Now the temperature is set. Now the system has taken the default timer which I have programmed in the program, that is 180 seconds. Now for 180 seconds, the microwave will go on preheating mode. And after that preheating, after this time, it will ask me to set the timer for the cooking items. So what we'll do, we'll check fourth mode. So it is on preheating mode. Fourth mode of operation. When I will press 4, it will go on the start mode. In this start mode, the default timer 30 seconds are set, and the microwave oven will start heating for 30 seconds. And after this 30 seconds, and I can stop my operation. Means I have successfully demonstrated all the four modes of uh, microwave oven uh, in this internship, in this project. So so that's all. uh, at last, I will cover the conclusion. In this internship, I have successfully implemented microwave oven simulation. I have gained practical embedded system experience. I have improved embedded C programming skills and understood real-time embedded system behavior. It provided me hands-on project-based learning approach and exposed me to the industrial level development practices. Thank you. I will like to thank and express my gratitude to the Emergy Technologies for providing me this opportunity.